Welcome to qnawire.
So in this problem, you want to derive this equation, which is B naught is equal to 1/2 B average. And this is just the magnetic field of the electrons inside of a betatron. And you can think of it as a circular object. So the first thing we want to do is look at the equation for the force of these electrons. And we know the force of the electrons is the charge times its magnetic field equals, and then mass times acceleration. And here we can say acceleration is the derivative of velocity with respect to time. And then now let's solve for that dv dt. So we have dv dt is equal to the charge times the E field divided by the mass. And dv dt is just acceleration. So this is the acceleration of the electrons inside of that betatron. And we know that the E field for these electrons that are moving in a circle is given by R over 2 ddt times B average. So we can plug this in and we get dv dt equals Q over M times, and then the E field becomes R over 2 ddt times B average. So next we want to find an expression for the acceleration, or the dv dt. And we can do that by the force of the B field, or the magnetic field, that's being produced here on the electrons. We know that the force of the magnetic field is given as Q times the velocity times the B field is equal to mass times acceleration. But here we're dealing with a circular object, so the acceleration is centripetal acceleration, which is given as v squared over r. And of course, 1v cancels, so we're left with Q times B equals mass times velocity divided by r. Now let's solve for velocity. So multiply r to both sides, divide by m, and we get r times Q times B divided by m. And now we can take the derivative with respect to time of the velocity, which we get as, again, r times Q divided by m. And a derivative with respect to time goes to the B field, and we end up with ddt B naught. And so now that we have a expression for dv dt, we can plug that back in to our equation over here. So we get on the left side r Q over M ddt V naught. So the acceleration on the electrons equals what we still have over here on the right, Q over M R over 2 ddt B average. We can cancel a few things here, so we can get rid of the R's, get rid of the Q's, get rid of the M's, and the dTs on both sides. So then we're just left with, so on the left side, B naught. On the right side, we still have 1/2 times the B average, which is the exact equation we're looking for.